Excellent! I can't believe that worked! I can't believe that worked!
And it should be alive. Yes. It lives. More or less. Excellent. Seriously. Once I get through these tutorials, first project, build switches for scenes, because that would just be infinitely helpful for me. Oh, it would be so lovely. Definitely what I'm doing. What is it, Arduino? That right there. So yes, it's a microprocessor that lets you do a whole bunch of cool things. So for anyone who missed the stream I did earlier today, I'm working my way through a beginner's kit, trying to pick up code information and, learning a whole bit of... I've messed around with this very briefly in the past, but I'm still pretty clueless when it comes to it. So I'm trying to teach myself, because I can use this to make, one moment. Let me actually give you a nice example. That's the wrong mouse. Two mouse... Really confusing. The controllers. We'll get there. You can use boards like this to make awesome things like this. So that's what I'm doing. I might mess around with other stuff in the end, but right now my goal is to learn how to make boards like that. Yeah. And take it as far as I can. I don't know. Can you even have things such as like dead zone customization? I'm guessing you can. Could you have curves calculated? Could you put in joystick curves? I don't know. Yes, this is also used for ED tracker. So man, I need to hurry up and get an ED tracker. That or just buy the parts. So it's one of those self-learn kits, age 6 to 12. Well, if you've got some very intelligent 6 to 12-year-olds, I guess. Well, actually, no, there's plenty of 6 to 12-year-olds that could do this kit, to be honest. But it doesn't say 6 to 12 anywhere on it, so that makes me feel better. Alright, so that's the plan. Earlier today, by the way, this PDF is available online from the Freetronics website. Earlier today, I worked my way through the beginning of all this stuff. We went through projects 1, project 2. Now we're about to get started on project 3. So yeah, all we've done so far is project 1 was to make an LED flash on and off once a second, and of course you could vary that. So that's the first one we did. The second one we did was project 2, which is, as you can see right here, to make LEDs flash at different intervals using this lovely code right here. So now I'm jumping on to the next one, which is getting slightly closer to what I want to actually learn. The project 3 is reading digital on off input. So it's the first time I'm going to actually be using a switch. Switches, are important if I want to build controllers. Man, I'm debating if I should turn off autofocus or not, because sometimes it seems to help, and other times it's terrible. It is decided, though, if I do this a lot, I need at least a cheap camera, because web cameras are terrible at close range. Although I wonder if I could get a lens on you. Yes. We're now going to begin on digital. I was planning, to be honest, on playing games tonight, but I got started on this and I want to keep going. I was hoping to spend some time learning the code necessary, but I haven't. At least I started reading a book. I got a book downloaded, and that's about as far as I got. Well, I read the first few pages, and then I realized that I'm not going to have time to do this before my stream, so I decided to save it for another time. I have... It actually loads. Come on. Taking a while to load. I think it's downloading the whole document. See? Second edition. What should hopefully be a useful book to get me started. What's needed for the programming side? I think, well, for Arduino only, pretty much just that, C, I think. But might be a little more complicated for me because I also need it to be able to talk with a computer through a USB port and pretend it's a joystick. So in the end, I don't know, but right now it's just C language. Well, it's nice to see you trying to broaden my horizons, yes. Like I said, I actually have used one of these before in a small project to control a robot. But by control a robot, it was a line following code, so it wasn't, and it was mostly just copy and pasted. I didn't really know what I was doing. The code worked, but that was out of luck, not because I actually wrote it. So that now I'm actually trying to get to the point where I can, write it. Like from scratch if necessary. Well, of course, for most things you won't. You'll take someone else's perfectly good working code anyway. But if you can run it from scratch, if something goes wrong or if you need to modify something, you can actually do it. Alright, so let's get started on this. The first two projects operate on their own once you start them up. They begin doing their thing without any input control from you. Detecting button input is a basic building block that you can use for all sorts of interaction with your project. So we'll build on the previous projects to add a button that you can use to control the state of your display. Alright, here we go. So, for the components we need the circuit board, already here. We need 8 LEDs. I've picked green because this is me. We need 8 470 ohm resistors, which are already in the breadboard, right there. Momentary push switch, which was included in the kit, of course. And I have that thing here with its adorable little click, and I'm not actually sure. I think you can hear it. The gate might be letting the sound through. And then we need a 10k ohm resistor. Okay, so that's something I'm gonna have to pull out. Now I'm gonna not cheat, and I'm actually gonna use the resistor code at the back. So 10k. That means it probably will be brown at the fourth one. If I was to guess. Now, which way around is this? Alright, so this one's around this way. Yeah, so it's probably this one. So brown is 1 and 2 blacks 100 times 10. So yeah, 10k right here. Let me check that, I actually got that right. Brown, black, black, red, brown. Well, I didn't pay red. Red? Maybe I got it wrong. That sounds like this one. Because red times it by 2 zeros. Let me think for a moment. Oh, wait, 10k. Okay, yeah, they're right. I'm wrong. It was 10k. I was thinking of 1. Or at least that's what my maths were doing to me. So you see, that's why it's good to have a double check. Alright. Let me just think about this, though. I'm going to go through it on the board, the check sheet, and make sure that it works the way I think it does. So I got 1, 0, 0, and then 2 zeros added thanks to the red. So yeah, 10,000. 10,000 ohms. We're good. We're good. I made a mistake, which is to be expected, to be fair. There's going to be lots of mistakes. If you should not be watching this stream to see an expert in action. Maybe one day I could be said expert, but maybe, 12 months down the track. We'll see. Alright, let's get on. Alright, so we've got that. We've got the jumper wires still here, ready to go. Plenty of them. The solderless breadboard still connected. We're good. We are good. Alright. There is the layout. I could just copy that layout exactly as shown there. Interesting. What pin are they wanting me to use? Pin 2, by the looks of it. I might just put things in exactly as shown there, because it's easy. How this thing has 4 inputs. I wonder how that works. Do they all connect when you push it down? Or does direction matter? I better wait and make sure that direction doesn't matter. So let's actually read the instructions, shall we? Cool. Hardware assembly. Once again, the project builds on the previous one. So if you've just finished your last project, you can use that as a starting point. Otherwise, go back to the instructions from project 2 and assemble the 8 LEDs in their matching 470 ohm current limit. Next, insert a push button to the solder's breadboard as shown, paying attention to the difference in spacing between the pins. If you look closely, you'll see the pins are in 2 pairs, slightly further apart in one direction than the other. Okay, I think I can see that. These two are further apart than those two. Even though the button has a total of 4 pins, that's only to make it mechanically stronger when it's mounted. It really only has 2 connectors, which are doubled up so that it can have 4 pins. Internally, the buttons are collected along the long sides of the button. If you orientate it as shown in the breadboard with the long sides spanning the central gap and connect one wire to the left button, one wire to the right, it'll work. I understand that. When it said right and left, except it's up and down that they connected it to. Oh, wait, never mind. I understand. Yeah, even though it's above, it was above and to the left. All right, so we know how to connect it now. Long ways. Breadboard. With a 2 gap. Not that it probably matters that much, but better be careful and try not to break anything. Think that's in? I see the words, but they could just well be Chinese. Don't worry, I am learning as well. I have tons to learn. But yeah, I have some background in electronics, which helps a lot. My main weakness, I'd say, would be programming, if I was to pick one. Yeah, I wonder... This doesn't want to fix securely in. It's a pain. Just do it. Looks fun. I'm enjoying it. Oop. While all that was going on, I disconnected one of the LEDs accidentally. It's alright, it's reconnected now. But yeah, just doesn't want to go in. It's boggling my mind. There might be a trick to getting it to stay in. Maybe, like, you'll notice that the pins are bent a little. I wonder if I need to unbend them to make this work. Let me try and just put it into any other one. A little peculiar. Should get a needle nose pair of pliers and try unbending them. Chances are I'll break something. And it'll all fall apart. It's certainly not staying in there, even remotely. Let me try a different one of the momentary switches, just to see if there's... Oh, come on, they look perfectly identical, but I'm going to try it anyway. I think you need to unbend them. Well, I could just leave it in there. It'll probably work even if it's a bit loose. It just makes me nervous. Alright, that one actually seemed to go in okay. Yeah, that one's in. I wonder if I accidentally bent pins on this one incorrectly or something. Maybe. I hope not, but it's possible. Alright, well, this one is in. If I need all 4, I'll worry about it then. But for now, seems to be working. Alright, so let's get on to the next part of connecting. Connecting resistors and wires. I don't need instructions on that. I've done that multiple times now. We're just connecting the resistor. Connecting the resistor to the ground. Cool, got it. Connecting it from the negative side, interestingly. Alright, well, let's go. You know what? I'm going to do the safe thing and unplug the power. I should have done that already. I mean, as far as I've been told, it's fairly safe. It's very unlikely you'll do any damage to your circuit. But, you know, It's no doubt safer without power running through it, regardless. So let's do that just to be on the safe side. All right, so that's one in. We need 2 more wires. Preferably a long black one for the ground. Do they have any more long black ones? And these wires are such a mess. Doing good. We're doing good. Oh god, it's everywhere. See, as I good, I'm much better at blowing things up. Safer for my hands. Honestly, these electronics using such low voltage, it's not a risk to me, but it is still a risk to the electronics. I mean, maybe if I start licking the electronics, then I'll feel some shocks, but it'd probably take that. Unless, I guess if I start using capacitors, then that might be a little different, but no capacitors in this one. Can't find another long one. All right, so we're not going to use the convention. We're using the 5-volt output. Try looking at it before you're putting it back in. In school electronics, me and my partner never successfully completed any of the projects. However, you came in first in the theory exam. I don't know if you can hear that, but there's a teenage party next door. Just constant screaming. And I'm not even the cause. Yes, I have a link to the kit I'm using. Give me half a moment. That said, if you just go to freetronics.com, you'll find it pretty quick. But yeah, I should have bring up the kit. And on this site, it actually has the PDF. Interested in that document I'm referencing, which is why I don't mind showing the PDF on the stream. I mean, it's shown online anyway, so it's not like it's some secret. There we go. That's the one. Can't hear it? Count yourself lucky. Alright, so we've hooked up the ground. We've hooked up the 5-volt supply. The one thing we haven't hooked up yet is one from pin 2. Right there. To in line with the resistor. Yep. Why does it actually require that? Now I'm actually thinking about it. Why does it need the resist? Like, Look young enough to join the party. Oh yeah, definitely. Definitely. I'll blend in. No one will ever tell the difference. Run fast when you hear sirens. Where to? Well, like I said, I'm their neighbors. There's nowhere to run. Let's just steal all the candy and then run away. Alright, so I'm just debating what would actually happen here. So we've got the 5-volt supply running through the switch. I'm trying to make sense of this. Beret makes you look like a 17-year-old. I'm just debating. How this works. Alright, so normally normally this pin is just going to have a complete circuit straight to the ground. Unless I open up the button, in which case this is going to be outputting. So is the 5-volt. Let's read all the documentation and we'll see what's going on. It just seems weird, the setup. I'm sure it makes sense. We'll see. Let's continue. So everything's wired up now. I'm going to start to read. Next, wait, so we've done the push button. Ideally, the button pins are connected along to the D2 digital pin. That's what the green wire is for. All right, the 10K ohm resistor is right here. So, like, yeah, that's been done. And a jumper wire to connect from the side of the button to the 5-volt header on the Arduino. All right, how the hardware works. The LEDs work just like in the previous project. Each one is a simple... By the way, now I've finished connecting up hardware. I guess I can power it up again. Oh. So far, it doesn't care that there's a new button because I haven't told it to pay any attention to that. So, button is doing nothing. But that's to be expected because I haven't changed the code. All right. So, yeah. So the LED is working just like in the previous project. Each one is a simple series of circuit that goes from the matching current limiting resistor through an LED and to the ground or 0-volt. For more details, see the previous project. Cool. The button and 10K ohm resistor and associated jumper wires from the circuit that pull Arduino digital pin D2 down through 0-volt. Wait, down to 0-volt through the resistor. This is called biasing, where a resistor is used to connect a digital pin to a certain voltage, in this case 0 volts, so that it tries to be at that voltage. However, because the connection goes through a resistor instead of directly through a simple piece of wire, it's not pulled hard to that voltage, and it's possible to override it and force it to a different voltage if you want. Okay, so I think I understand. Because pin 2 is not like, I don't understand everything, admittedly, but because pin 2 is currently connected to the ground, which is 0 volts, through a resistor, it's currently imitating that voltage at 0, but it's only a soft limit, so it's very easy to force it away from it, which is why when I push down that momentary switch right here, it should put the voltage at 2 and boost it up to 5, because the voltage, this 5 volts will completely overwhelm that resistor, I'm guessing. But we'll see. Let's continue. The terms high and low are commonly used, often capitalized to describe the states of parts of a digital circuit, and you'll learn them in many places in Arduino sketches. You'll often see statements like pin 13 in low state, pin 7 in high, as discussed in digital circuits. What this button circuit does is allow the sketch running Arduino to detect when the button is being pressed, because it can measure the state of the digital pin connected to it. If it measures the state of the pin and discovers it's low, it knows the button isn't being pressed. If the pin is high, it knows the button is currently being pressed. In a moment, we'll take advantage of that to use the button to change the behavior of LEDs. Glorious water. And the whole living thing. Alright, so this is the software. Open a new sketch. Put the following code in. Okay, you don't copy and paste from the PDF, as I've discovered, because that never goes well. So instead, we're going to go here. Copy from this location. Need a new sketch. Close the old one. Realize I should change the view to something more useful to everyone. Sorry, one moment. Alright. So I've just opened this up. Copied this. Now we're pasting new code into there. Oh, the new code is in. Let's see what type of instructions they give us. Oh, wait, that's right. Wrong. There we go. I was going to say, wait, there's no more instructions? What? Ah, that looks a little better. I've been playing around with layouts. Definitely nowhere near optimal yet. Fact. Speaking of nowhere near optimal, realized I want to change something. Ah. Oh, this is ridiculous. Right. So we've just put in that code. Now, how the software works. Most of the sketch is identical to the scanner sketch in the previous project. So the one that's making these LEDs go back and forward like that. However, this version adds a pause button. Interesting. Near the top of the sketch, the button pin variable is set to value 2 because the button is connected to digital pin 2. Have a quick peek at that. Here. So yeah, button pin is 2. So yeah, now whenever we want to use the button, we refer to it as button pin rather than pin. Cool. Inside setup, the button pin is set to be an input so that the sketch can read from it and detect whether it's currently at high, 5 volts, or low, 0 volts. Remember that we have a 10k ohm resistor biasing the input low. So most of the time it will be at 0 volts and will read low. But when the button is pressed, the input will be pulled to 5 volts and will read high. Cool. Finally, inside the loop. So if this works the way that I think it does, pretty much normally the voltage coming out of here has to fight against a resistor, and it's very, very weak, so it just drops down to 0 volts. But when you activate the push button, it gets a high 5 voltage supply that just, you know, completely dominates the resistor and clears the way for high voltage from this guy. It's the way I think it does. So it actually makes sense now, assuming that, you know, I'm semi-correct in how this works. I'm not, to be clear. Still playing with how I like this looking. One moment. Have yet another idea. I really am going to have to spend a long time messing around with layouts and trying to work out what works best. It's a learning experience. Seems that party's gone up a few decibels. You can hear them now too. Oh no. I'm so sorry. See, now you can see the project in reasonable detail, as well as the programming up the top and the instructions over there. Crazy. Try removing the 0 volt resistor and see if it still works. Well, it won't. Well, I'll wait and see. But if it works the way I think it does, by removing the resistor, yeah, if I remove the resistor, well, one, I'd have to put a wire to bridge it to negative. But then, just because there would be 0 resistance, I think it'd always read high voltage. Yeah. I haven't even uploaded the code yet, by the way. That will come in a little bit. Alright. So, when the button is pressed. So finally, inside the loop that scans the LED, there is a new section of code. While digital read, button pin equals high. Okay, that's a new code that I haven't seen. Delay 100 milliseconds. This is another loop called a white loop. The loop has a condition declared, and as long as that condition is true, it will keep repeating itself. So while, I'm guessing, is the important phrase there. In this sketch, the loop condition is that when reading from the pin while the button is pressed, the value must be high or 5 volts. If that condition isn't met, the loop will exit and the rest of the program will continue. But if the comparison is true, it will keep doing whatever is inside the loop. In this case, there's nothing much inside the loop at all except for a call to delay 100 milliseconds and then go back to the start and check the button again. The result is that as long as the button is held down, the reading will be high. The condition therefore will be true, and the loop will just keep doing it again and again. So the program cannot continue and the scanner will stop. Release the button and it can fail, and the scanner will resume as before. Okay, let's mess around with this. While the loop is a simple one, just one condition and keeps on going as long as it's true, yeah. Well, let's upload. Board. think it just uploaded. Alright, so it's slowed down. Yeah, the LED delay is down, is back up to 300 milliseconds because I sped it up because, you know, speed. Let's try pushing down the button and it should pause. Upload the code and bring it to the party. They'll love it. Yes, I'm sure that's exactly what some young teenage girls want to do. They want to play with Arduino kits. Just the thing. Let me actually have a look at the code now and try and understand what happened. So, this part I understand. This was in the previous one. The interesting new stuff is in the void loop. So it starts the loop, and digital write LED pin this LED high. Aha. So yeah, it puts the LED on high. It does the delay. After it's put the LED on and it's checked for a delay, then it does the while command. And it checks to find out if the button pin 2, is currently in a high state. If it's in a high state, that being true, it'll start doing this loop. And as soon, if it's in a low state, it skips the loop and just goes straight to digital write. It's low. So that one's actually, compared to the last project that gave me so much headaches, this one went a little bit easier. I think it's because I'm starting to get the hang of this code a little bit. And a guy with a beret. I wonder how their parents would react. If I show up there with my beret holding out a circuit board. Play with me, play! Let's all sit around and make some LEDs flash. Anyway. Just playing around with it now. Now, I think if I remove... I'm going to try doing this. But if it works the way I think it does, by removing the resistor and replacing it with a wire, it's always just going to be set to high. Oh, actually, I'm worried. Am I going to blow something up if I do that? Really not sure if I want to. It's all still just Chinese to you? Well, yeah, admittedly, it's pretty crazy stuff. Might think I'm a bomb maker. Make the button turn into disco mode. Can I set... Well, it's called an experimental... God. Alright, I'm just realized, I'm like, if I put the 5 volts directly... Yeah, I'm not sure I want to risk putting 5 volts through there. One thing I can do though. Let's unplug it. I'm going to disconnect the 5 volts. As long as I'm not playing with that direct 5 volts, I'm not as worried. Now, I'm going to remove that 10k ohm LED. Cool. And now, well, actually, at this point, connect it directly to the ground. Move that directly in line with the ground. And I suspect that when I turn it on, it's just going to go to the first position and stay there. Because it's going to be in a high state, and that won't leave. So, let's try. Cover your ears. Making a liar out of me. You don't work the way I thought you'd work. I'm very mad. Dang it. Because I just assumed that a high voltage would get through in that case. Apparently, that's not how it works. It made a liar out of me. Made a liar. Bad. Alright, let's unplug it. No boom. I don't even know why it didn't work then, to be honest. Alright, let's plug it back in. Liar, liar, pants on fire. Now I'm going to plug in the ever so deadly 5 volt supply again. The ever deadly 5-volt supply is plugged in. I am plugging back in the Arduino. It is powered once more. Let's just check it still works. Just seems to... It's skipping this LED on the way back. Let me watch that. Yeah, why is it skipping that LED on the way back? Have I done something wrong with my code? Go straight from that one to that one. What's wrong with the code? 6, 7, 8, 9, 10, 11, 12, 13, 12, 11, 10, 9, 8, 7. What's going on? What is going on? I really don't know why that is. Maybe I've got one of them in the wrong plug. In 6. Why aren't you working? LED count -1. Don't know. I didn't write any... Wait, that should work for disco mode. Might be wrong, but I think it should be LED count -1 or LED count. Well, it says LED count -1. Let me try just LED count out of interest and we'll see what happens. Please don't explode. 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 Yeah, that's it. This is code I copied straight from... Seriously, I wonder, do you think the designer put errors in the code just to force people to try and work out what was wrong? The code is just head coding, so no guarantees that it works. One moment. Unfortunately, I don't have my Twitch chat open on the PC that I'm doing the programming on. Accessing that is easier said than done. Alright, so anyway, this code is working, so that's cool. One thing that I'd like to, one thing I want to try and experiment with, I want to experiment with, instead of the push button stopping the jumping back and forth, I want it to speed it up. How can I work out how to do that? What we need to do is change LED delay while that's going on, or... Don't mind me. I'm just thinking. Not very successfully, I might add. That's weird. The codes that he described here and the code here is actually a little different. Look, his delay here was 100. The delay here, and it's more prone to accidental errors. Increase that up to 100. I don't think it won't make much difference, but it should mean that, you know, if the connection is just lost for half a moment, it's more likely to stay. All right. The delay in the loop only decides how often it's checked or not. Well, yeah. Sorry. No, the delay that I want to change isn't the delay here. I don't know if this is possible to change one of these prefixed values at the start. All right. Can you change a value? Like, could I put? I don't know if this is. The values at the start are meant to be changed. Well, let me try this then. Except, alright, here's the thing. I don't want it to keep looping. Press that. Just remove the int. Ah, so you just do CD delay. Alright, let me see if this does anything. Still going to work just the way I want it because while I've got this held down, the lights will stop moving. But at the very least, when I release, they should start moving quicker. Yeah, now they start moving quicker. So that's working. Now what I want though is that when I... Yeah, what I... Two things that I want. I want it so that it doesn't pause when I hold down the button. And I want it so that when I release it, it goes back to the slow. So that it's a matter of how to do it. So I don't think while is what I'm doing. Maybe if? Does if work? If you remake while into if, it won't stop the cycling. Aha. Copy of that. Dang it, what have I done? Sure, I've done something silly. I just copied and pasted it. What could I... Maybe that's not... Oh, wait, I see. Oh, ha, ha. At least I think that's what is wrong. Cool. Let's see if this works. Get out of the way, microphone. Pretty exciting. So now when I hold this down, it should speed up. When I release, it should slow down. The moment of truth. Yes! Now it's sped up while I'm holding it down. Is it going to slow down when I release? Yes! I'm learning. We are learning. Booyah. Brilliant. Pretty cool. Pretty cool. Such a simple thing, yet so much joy. Yeah, I know. You can replace the second if condition met with a simple else. Ah, yeah, good point. How does that go? Just else. Then do you hit format it? Nope. Else. And then I need to put another... Ah! What do you know? Brilliant! Oh, yeah. This is still a long way from the type of stuff I want to be able to do, admittedly. But it's still, you know, a step in the right direction, and that's the important thing. If no one makes a game controller the way that I want it, I'm going to make my own, damn it. I will have my ultimate space sim controller, even if I've got to make the damn thing myself. Whee! Anyway, let's stop with that now. If you, by the way, if there's any code you want me to actually try just for the hell of it, feel free to yell out. What is the next step in my master plan? Continuing to learn. So let's... I've now completed this part. I understand most of it fairly well. Now let's go on to further experiments. Let's see what they suggest. 1 year later, Thorn will build a Death Star. Excellent. This project is controlled by a push button that provides a simple yes or no value, but it's not just buttons and switches that behave this way. Many other input devices have a simple on and off values that you can read just like a button. So the skills, by the way, that's very important for me because, you know, one of the things I want to do is buttons. Many other input devices have a simple on-off values that you can read just like a button. So with the skills you've learned so far, you can already replace the button with a variety of devices such as security, system motion detector, or thermal switch, or tilt switch. I just realized something. Did they? Ah, yeah, here we go. One thing I just realized that I didn't do, but they already did in the code, was set pin mode, button pin input. I didn't do that. I was just remembering, wait a minute, we didn't set it to input. But they did, because I copied their code. Can I make something like this? Probably not, but I'll have a look. So what the frack? What is that? Guessing that took a while. People doing stupid stuff with a logic system in Factorino. That's different. But no, I cannot do that yet. Notice I say yet. Anything's possible given enough time. Taking over the world incoming. It's millions of LEDs. Oh, Jesus. I wonder how hard that was for a computer to run. Oh. That's really annoying. I still haven't heard from the electrician. Dang it. And it's Friday, so I'm not going to be hearing from him this week, given it's, 7 p.m. Alright, so the further experiments part will move on now. We're going to go on to Project 4. Reading an analog variable input. Okay, that looks like the breadboard is pretty much... Yeah, it's not like anything like the current project, so I'm actually going to strip the breadboard back to bare. Well, actually, I'll read the project first, but in the meantime, I can leave these pretty lights blinking back and forth. Very important. Except biting your own nose. Well, you could. You just have to chop it off first, and that doesn't sound like much fun. So, yes, I might skip doing that. We've already made great progress. Now, this is a very important one for me as well. Digital inputs, like variable inputs are going to be very important to, well... Like, one of the things, I have found a Hall Effect analog thumbstick that I want to buy. One of the reasons I haven't bought it yet is because it sells in multiple versions that have various outputs depending on its position. And I haven't known what output to get because I don't know what Arduino likes to work with. So hopefully I'm going to learn in this. And then I'll know at least which one to order, and then I can order it. And we'll be one step closer. Anyway. So far, I've made really great progress with digital inputs, outputs, to turn things on and off. We can read from digital inputs to detect a simple yes or no event, like a button press. For many projects, that's all you need, but sometimes you need to do more than just measure simple low-high states. You need to be able to measure across a range, and measure the level is something that is not totally off. On. In this project, we'll measure the level of light in the room and show how to send that value to the PC so you can read it. Send it to the PC? Really going to be that fancy? We'll see. I hope so, because that's, first part of communicating with the PC, which I need to do. In this project, we'll measure the level of light in the room and show you how to send. Alright, never mind. Yeah, send value to the PC. We've done that. Okay, so components. Alright, let's unplug the power. Goodbye, flashing LEDs. Let's unplug everything. Cool. That momentary switch, the one that actually works. I don't know why that other one didn't want to fit, but it doesn't. Green LEDs. Much as I will miss them. Apparently I can leave one LED out. They pick a red one, but I'm not going to pick a red. I'm going with green. Great that way. This is the 10K resistor. 470s. So I'll need to hang on to one of the 470s. Hang on to this 470, put it down there next to the green LED. The light sensor. Where is my light sensor? Here is the light sensor they gave me. Thorn the Rebel. I know, oh, I'm such a rebel. So we've got the light sensor. What else do we need? Jumper wires. Well, they're here, so I can access them at will. That's it. Alright, we're good to get started on hooking up this project. Now let's see if there's any advice for hardware assembly before I start plugging it in. If you finish the previous project, you can leave the rest of your circuit in place if you'd like. God dang it. Really? But for this project, we'll go back to using just one LED. It'll be connected up just like in project 1, but instead of a digital pin D13, this time we'll use pin 11. Connect to jumper wire from D11 through to 470 ohm resistor, and then to the LED, and then to ground as shown in the diagram. The light module has 3 connections. They are designed to have a header or wires soldered directly to them, so make it easy for you to use the module in your solderless breadboard with pre-fitted header pins. Ah, I see what they mean. So normally this would have come with just 3 holes here. In other words, and for this, so that we don't have to do soldering, they put this little piece in here for us to make our life easy. Or you can just plug them in and use the jumpers to link them. Yep. All right, so the 3 that we've got, the ground, the connection on the left needs to link up to the ground on the Arduino. Cool. Yep, it says ground on it, so the one on the far left. The out connection in the middle needs to link to the Arduino 0. The input 0A down near the bottom of the Arduino. And the VCC connection on the right needs to link to the 5-volt on the Arduino. Oh, wait, to analog input A1. Cool. All right, I'm going to get a drink. I need it. I've returned with a drink. All right. So how the hardware works. The LED connection should be very familiar to you by now. Yes, because it's the same as the one used in the first 3 projects. An LED and a resistor in series connected to a digital pin at one end and the ground on the other. Cool? and it's pin 12, I think. It'll be listed on the diagram. So that when the pin is high, the LED illuminates, and when the pin is low, the LED is extinguished. I love how they use extinguished, such a fancy word. This is a nice surprise to tune into, though. Make-a-thon. Hey, I'm only doing this to, like, let me be clear. I'm only doing this to help me blow things up better, alright? Sometimes to destroy, you've got to build. The interesting part is the connections to the light module. The module needs ground and 5-volt connections as a power supply. So that is easy. Well, yeah, the 5-volt, the ground and the 5-volt is easy. Then when it's powered up, it reads the intensity of the light that is falling on it and changes the voltage given on the out pin proportionally. If the module is in complete darkness, the output will be very close to 0 volts on the out pin. When the module is in intense light, it will be very close to 5 volts on the out pin. When it's dim light, it'll be somewhere in the middle. Makes sense. So by measuring the voltage on the out pin in the range of 0 to 5 volts, we can tell how much light is falling on the module. Be a means to an end. Yes, yes, definitely. Now you understand. Remember in the previous project, we measured whether a button is being pressed or not by reading one of two states, high and low. That was a digital value that was being read because it could only be one of those two states. This is different because the output from the light module could be 0 or 5 volts. It could also be anywhere in between. And we can't read it as a digital input because it could be 2.865 volts. What does that mean? Thorn handcrafted hardware Kickstarter incoming. I need to get a hell of a lot better before I'll make anything worth having. Signal that can have values anywhere across the range is called analog. Yes. The Arduino has a block of 6 inputs at the bottom right, specifically designed for analog. So the bottom right, yeah, you can see analog 0 through 5, so 6 of them. Software. Open a new sketch, type the following code, or copy and paste it from the website. Well, we're doing it from the website because it fails otherwise. This is number 4. New. Old one. Paste. Alright. Cool. Now let's actually assemble this the way as instructed. So, oh, that's not what I want. That's what I want. We'll go back up to the diagram provided, and we will make that happen. At least that's the plan. Seriously though, I really, really need better like buttons to press to switch between scenes. I also need to come up with a better setup, but we'll worry about that later. All right. Where do we want to start? This thing, the very start can go here. Dabbing it in. Come on. All right, now it doesn't. I probably shouldn't force it too much, otherwise it's, probably suggesting something's gone bad. Man, I'm surprised it really doesn't want to go in there. Why not? Do it. All right, now it's gone in. I just went the next one lower. Maybe that was a good idea from the very beginning. So that's it. Yeah, I know. I could actually program an Arduino to switch between scenes. That's actually, I'm thinking one of my first cool projects could be to actually just make a control board. Yeah, just have a whole bunch of switches and just tape on what scene that's going to switch to above it. Very handy. But, later. Later. We've got plenty to keep ourselves busy for the time being. All right, let's get this back in. Which side does the positive go on? Positive goes to the right. This LED. I also need a decent camera to actually zoom in on this stuff. God, I need it. I always thought a better camera would be nice. This is the first time I've really thought it's almost essential. Go, that went in. 1 month later, Thorn has 300 switches next to my monitor. You honestly know the truth? Probably, knowing me. Probably. Like, my streaming setup is already absolutely insane. I am an eccentric person. Without a doubt. Yeah. What else can I say? I do crazy things. So, that's that in. Alright, now we just need to hook up all the wiring. So. Yeah, why are there no long black ones? Well, I've got one semi-long, but it's not as long as it could be. Hook this up to the negative. And this can go to the ground. Perfect. Alright, on to the next challenge. What do we got? Analog 0 input. What? 0 input? Should it be 0? Serial begin. I swear that's not what the instructions said. Maybe it is. Oh, I'm just going to follow it. If it doesn't work, it doesn't work. That should go to the middle pin. Cool. We just need a little one up here. So now I'm putting in the one that connects the ground on the light sensor to the ground on the breadboard. So that's just a little jump and a hit, jump and a scoot, jump and a hop, something. All right, next, let's hook up the 5-volt supply. I believe it is. Yes, it is the 5-volt supply. Do I have a long red one to stick to at least semi resemblance of normalcy? And I do. So that's into the 5-volt. We bring that to the 5-volt supply. Here. In it goes. Excellent. Going excellent. All right. Now, last but not least, we need one more wire. We'll go with blue to copy the sketch, because why not? And we need one more wire connecting pin... pin 1? Right. Pin 11. There's 2 1s there I should have paid attention to. And then we hook that up to the positive, the LED. And I just realized something. My LED, I put the resistor in the wrong location. It's currently hooked up to the positive. The easier thing to do is probably going to move to LED one down. And it's moved one down. Excellent. All right, that should be hooked up. Yeah. I'm going to, just out of interest now, I'm actually going to upload and run this program. I don't know if it's going to do anything. So, let's swap back. View. And upload. Nothing's breaking yet. Yet being the key word. Done uploading. Apparently it uploaded. I have no idea what this code's actually meant to do. So, apparently whatever it's supposed to do, though, isn't happening. because nothing's happening. Let me read through the code. Serial print light level. Right, let's actually read through what the code's supposed to do. The interesting part of this sketch is the use of analog read to measure the voltage currently being detected by the analog input. The analog input on the Arduino returns values in range of 0 to 1023. If the voltage is at minimum 0 volts, it will return a value of 0. If the voltage is at a maximum 5 volts, it will return a value of 1023. If the voltage is exactly the middle, 2.5, it'll return a value of 511. Right now, you're probably thinking, what is the maximum value? Why is the maximum value 1023? Prime number? And why is the bill reading 511? That doesn't make any sense. Why couldn't they make it 0, 100, 0, 1000 or something? May not make much sense when you see it at first, but there's very good reason values from 0 to 1023. And the explanation is quite complicated, but it's to do with the fact that there are special circuitry inside analog inputs that take a continuously varying level and break it down into a series of distinct steps and figure out which step the voltage is closest to. There's a very detailed explanation of the process in the book Practical Arduino by Jonathan. Look it up. Right now, just accept that 0 is the lowest reading, 1023 is the highest, and the rest of the range is spread evenly between these two limits. Having read the light level of the module and obtaining a value somewhere between 0 and 1023, the sketch then uses that value to decide how long to wait each time it turns the LED on off. This gives us an LED that will flash at different rates depending on how bright the light is. Because if the light level is low, the delay will be shorter, and if the light level is high, the delay will be longer. Try putting your hand on the light center and see if the LED flashing changes. I'm going to unplug it for a moment and just make sure I put in the LED the right way around. Positive is the long one, negative is the short one, plus it has the indent. So that's correct. I'm just going through. Oh, I know what I did. Yeah. In fact, this is really stupid of me. Admittedly, it's kind of stupid of me, but it's also, I'm blaming the fault of the diagram. I followed the diagram when I shouldn't have. On my board. Yeah. Actually, wait, no, that's right. I'm doing the other side. So yeah, my resistor is in the wrong spot. It's currently in the positive. It needs to be in the negative. Must have been using the other board last time, because last time the negative was like the bottom one, and the positive was top. And yeah, if you look at it, it's opposite on either side. Not that you you'll just have to believe me. Alright, let's plug it back in. Aha. So now I've got a flashy light. So now it's actually doing something. So now if I cover up the light, I think the flashing gets faster. So it stays on. Then as it gets brighter, flashiness died. I believe the stream died. No, seems good. I can certainly still see it. I'm trying to turn on torch. Cool. We got the torch on my lovely phone. Now this should slow it down, way down as I shine it on it. Point, it barely flashes at all. Yeah. Cool. So this one is working. Now to make it go quick, I start putting it in shade. Let me check something. Does it only, I think it only scans for a new light sensor reading in between pulses. So if I'm really quick, yeah, there's quite a delay between it. Let me just check the code to verify that. But there's, like, it only starts flashing really quickly after it manages to do a cycle. See? I'm going to check and see if the code looks like that. I'm assuming it will. And I guess there would be ways around that if you really needed it to update quickly. Yeah, make it flash quick. Don't mind me. They use a delay to control the flashes, which means that, yeah, all the earlier code pauses. Isn't that poor coding? But I guess, that makes the code a hell of a lot simpler. They'd have to make it more complex and thus make it harder for people to learn. All right, let me try and make sense of this. LED is 11. And we've got another value set, which is light level. Setup, so this is runs once. Serial.begin, 38400. I have no idea why that means anything. Pin mode, LED. So it's setting 11 to output mode. Cool. Starts. I've got to learn what serial begin is. I'm guessing it's something to do with the analog input. Void loop, begin, light level equals analog read. Cool. So that makes sense. Sets light level, analog read. Serial, print, light level. Serial print. I don't know what that does. Digital write, LED high. Delay, yeah, will be whatever the light value is. And so the value can, the light value can be anywhere from, well, practically nothing up. If I cover the light entirely, the light value should go down to like 1 second. Wait, no, if it's completely illuminated, it should go to 1. Because that's about the highest this thing can do. Yeah, maybe it will show on my computer what the current value is. I hope so. Yeah, that's about a second between flashes. Oh. Alright. Check the bottom of that window if there's an output. 1 moment. I don't see anything. Like, let me scroll this up so you can see it. I don't see anything that looks like an output. Like, they might explain this further down in the text. I haven't gone the whole way yet. So let's go further down in the text and we'll see if it says anything. Because one reason I'm excited about the ability to do this is, who knows, like, one of the things I want to be able to do while streaming is easily show my joystick inputs. I wonder if there's any way to do that with Arduino. We'll see. Alright, so let's go back down and we'll see, we'll try and pick up where we left off. Oh, like, one thing I don't understand is, yeah, what serial begin is? Yeah, it's the serial parts I don't understand. Analog read A0 is self-explanatory. Read the, A0 input, which is the one right here. So that makes perfect sense. You have your serial monitor open. I don't even know what a serial monitor is. You've got, like, what's a serial monitor? Tools, serial monitor. Well, that's happening. What does that mean? You're definitely watching this later. So you could watch. Bottom right. Oh, set it to match what's in the program. That makes sense. 1 moment. Huh. Cool. Draw data. Unfortunately, I got a ubiquitous computing midterm. Fair enough. Enjoy. This stuff is far more enjoyable when, it's not... It doesn't matter if you fail it. Alright, let me try and do some modifications. So let's block it completely, and the light level drops down to practically nothing. Unblock it. Light level. jump up. Let me illuminate it with my phone again. We'll see how it reacts. And the light levels approach maximum. Not quite. Maximum being, what was it, 1023, but it's pretty close. That's cool. It is pulling data for me. I don't know if there's any way to use that data, but it's doing it. Made yesterday that your sound card on a Raspberry Pi working. Hell yeah, it works. I might have to mess around with Raspberry Pis one day. But for what I want to do, I think Arduino will do the job. Now remove the LED code and set a static delay time. And you get the sample rate of your computer at a steady rate. Yes, that's actually a good idea. Let's try that. Let's remove all LED code. Yeah, that's not what... Was that what I want? What does delay mean? Wait, I know. Get rid of that. Set the delay to 100 milliseconds. Not sure if you got it, but the serial being 38400 sets the serial transmission data rate in bits per second. Cool. Well, now I know. Because that's stuff that's going to be, that could be very important. I think if I remember right, Objects in Space mentioned something about them using serial connections or something for communicating. Da 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 da. Plugging them into a computer and access them via a virtual serial port. So maybe that's something similar? We shall find out in the future. You thought 38400 looked familiar, so you Googled it, fair enough. And yeah, now it's not changing speed depending on what I'm doing, so that's cool. How quick can I make this update? Because I know that some of the mouse you get are like, we've got 1,000. Like they check your rate, your position like 1,000 times a second. Let's try and bring that down to. In theory, to match that, I'd have to do 1. God, please don't break. 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 It's probably not managing it at 1 millisecond, but it's going quick. Yeah, it'll be just going as fast as the processor can do it now, and I don't know how fast that is. Don't mind me. I'm amusing myself with, you know, I'm a simple person. I can get amused by simple things. Just drop the delay? Yeah, fair enough. Because I doubt that delay is making any difference. I'd be curious what type of output. So for this output to go lower, you'd want a faster CPU, well, processor on the Arduino. That could be one reason. I think the Arduino Mega has a slightly faster output. Anyway, yeah, now it's running as fast as it possibly can. What do you mean, oh no? Anyway, maybe I should stop this program before it kills itself. Add a reasonable delay back in. Stop killing yourself. Behave. There we go. That's a little bit more friendly. All right, let's keep reading through the documentation. All right. How the software works. All right, I've actually already read through that. Actually, I haven't read through it all, have I? Try putting your hand over the light sensor and see if the flashing gets faster. Try shining a bright torch on it or putting it in direct sunlight and see if it gets slower. As well as varying the delay depending on light levels. The reading is also transmitted out of the USB port to a PC. I'm always just moving too quick. All the information that I wanted is there in the tutorial. I just need to keep reading. Alright. The reading is also transmitted out of the USB port on your PC as a serial connection so that you can see the value that is the analog input is reading. That is extremely useful technique that you'll want to use in many Arduino projects. Yes, I will. The data connection to your PC is configured inside the setup routine, including the communication speed. In this example, it's set to 30, it's all there, 38,400 bytes per second. So the sketch running on your Arduino and the PC still connected to the USB cable, you can click the serial monitor button on the top right of the IDE to open a communications window to see the messages sent to you by the sketch. Make sure the rate setting at the bottom, God, they're seriously covering everything that I messed up to match the setting in the sketch. Inside the loop routine, you'll see functions serial print and serial print ln use. I don't know what the difference between those two are, though. Those functions both set the data to the PC. Send data to the PC. The first just sends the raw message. The second sends the message and then also sends a new line character to the end. It all run together on the same line in the serial monitor window. Fair enough. Place the LED with a sound module. Now you combine this with the earlier multi-LED and make LED lights that light up depending on value. Well, yeah, Jurdik, I'm paying attention to the code because I need to. If I want to be able to do this stuff myself, I need to know this as well as, I possibly can. So further experiments. This example makes the flashing get slower as the brightness increases. How would you reverse the behavior so that the flashing gets faster as brightness increases? One simple way to do it would be to read the value from the sensor, then instead of using it directly, you could subtract it from 1023. Makes sense. I've already messed with the code too much though. Unless, how many undos does it let me do? Can I go all the way back to what I had? Whoops, what have I done? It's probably something really silly, like during my copy and pasting that I messed up. Oh wait, you know what's wrong? I copy and pasted it. I learned the... Oh, why did I copy and paste it? There'll be a hidden... Damn it, there'll be something hidden in there that I just messed up. Let's type it in manually. Unexpected before token. Still double, yeah. Done uploading. Now it should be the opposite. It's going really slowly when I'm covering it up. Now when I bring the light in, it should start going really quick. Let's find out. That's a yes, it's working. Cool. All right. I think we're mostly done with that project. Let's keep going though, and we'll read the rest of what's written. Reading of 0 will then give a delay of 1023. Reading of 1023 will give a delay of 0. Makes sense. Rather than simply altering the flash rates of a single LED, you can combine this project with a project 3 to drive 8 LEDs and have the delay duration vary the reading of the light sensor, so you could make the going up and down vary. Then the scanning speed will get faster as the light gets dimmer. What if you want to control the input manually rather than based on light level? For that, you can use a variable resistor, including the experimental kit. Connect one end of the connection to the ground and the other connection to the 5-volt. And in the middle, put the 0A analog input. Let me try that right now, because this is what I'm really interested in. Like, this is getting really close to the type of stuff I need to do. So, taking off the light sensor. Putting in its place this thing. Variable resistor. We need the middle one to line up with the analog input, which this does. Cool. Plugging it back in. I wonder if I can access the voltage levels coming out of like an old T16000. I'm gonna have to try that at some point. Uh-oh. I don't think it's come undone. Not good. Mayday, mayday, mayday. Weird, it doesn't let me push it back down again. Look at the serial monitor, good idea. Let's see what it's telling me is going on. Stop telling me anything. Serial monitor's not moving. So let's try closing that. There we go. Slow it right down. Now we'll raise it. I wonder if one of the problem is that it's raising too high and breaking it. That might be it. Let's see what level it rises up to. Yeah, now it won't. Now when I turn it down, it won't stop. Weird. Seems that if I get too high, I can't reduce it again. Wonder what could possibly be going on. Wait a minute. I think I might know. if I ever go above, oh god, this is the problem. I think the fact that this says 1012. Oh, let's try changing that to 2 and 3. Blame it on the silence. It's always the silence. Let's try speeding it up again. Now we'll bring it up to maximum. Interestingly enough, when it hits maximum, it stops working at all. It goes from flashing really quickly to just not on. Replace the LED with this one from your kit. The buzzer. You sure that's a good idea? Wouldn't I need some different resistor or something? At least I wouldn't be surprised. Getting a cold. Certainly not from the cold, I'll tell you that. LED can't keep up, probably, yeah. There's no polarity, and it's... Well, we'll see. If it blows up, I'll be very mad. Wait, I wasn't meant to unplug that. I need that still. But yeah, it is no polarity, so I can't mess that up. For reading that. Huh. Little clicking noise. Gotta admit it, watching someone learn coding is pretty fun, and seeing as you actually look at the code and not just copy and paste everything. Alright, one moment while I'm gonna have to turn off my audio gate for you to be able to hear this. And also turn up the microphone. Look out for the radiation. Alright, audio gate back on, volume turned down. I don't know if you heard that at all, but yeah, it's doing a little clicking sound. Why does it go click instead of beep? I don't know. Because it does. Alright, how about I go on to the next project? I've clearly finished this one. I've started doing things that I'm not really meant to do yet. Of course, eventually I can mess around with this stuff. Sounds like a Geiger counter, yes. It does have that, doesn't it? Oh god, that noise. Anyway. Unplugging and putting the sound device back for now. Playing Rust while having the stream up. Before it thinks you're in a radiation area, yes. Two in the box for now. Let's see what they want us to do next. Dimming an LED using pulse width modulation. Now we've done digital output, digital input, and analog input. What's left? Analog output. It kind of makes sense, I gotta admit. Close to making a music playing Christmas light. Now we've done digital out. Well, yeah. Sometimes you don't want things like LEDs to be fully on or off. You want them to be half on or quarter on. that's harder than it sounds, because to a computer, everything is yes or no, high or low, on or off values. Everything is black or white. Computers don't like gray. This is called binary logic, where everything is either 0 or 1. The outputs of an Arduino are the same. They're either on or off, but not partway in between. The solution is a trick called pulse width modulation, which I know plenty about because we relied on that to control electric motors with robots. That's one thing I know. This project will use pulse width modulation to control the brightness of an LED so that it looks like it's breathing, slowly pulsing on and off. Parts required. Board, check. LED any color, already in. 470 ohm resistor, already in. Solderless breadboard, already in. So I think we'll just remove. Actually confused. Actually, yeah, we'll remove all the analog related stuff. Like, we'll just leave in the stuff necessary for the LED. Oh, I should have left the ground in. Or should have I? Apparently not. Apparently I should just use the ground on this side. Well, ground on that side is being used. Wait, I removed the LED. What am I doing? I'm great. Alright, let's put the LED back in. LED is back in. Alright. Hardware assembly. We've done all this before. There's no hints I need there. Alright, how the hardware works. The circuitry is simple enough. It's just like the first project in this guide. Digital pins sending the current through an LED with a current limiting resistor to prevent the LED burning out. The interesting part is the magic inside the microcontroller that does the pulse width modulation output. Pulse width modulation is a sneaky way to use digital output and make it pretend to be partly on, even when it can't be. Most of the magic of the trick is in the timing. If you have the digital output going to an LED and you turn it on and off very fast, the LED will be fully on for some of the time and fully off for some of the time. If you do it fast enough, the human eye cannot see it flashing on and off. The human eye has a slow response time, which results in a phenomenon known as persistence of vision, or the flicker fusion threshold. Remember, human eye can only see 24 frames per second. If you want to make an LED look like it's about half normal brightness, it's easy. Just turn it on for a set period of time, then turn it off for the same period of time, and so on. If it's on about half the time, that's what engineers call a 50% duty cycle. And the result is the LED will be about half as bright as normal. Unsubs. What about other brightness levels? If you want to make it... Wait, if you want to make the LED look like it's at a quarter brightness, easy. Just change the relative times of the on or off periods. That's why it's called pulse width modulation. The width of the duration of the pulses that changes to give different output levels. To achieve a quarter output, or 25%, you can just change the timing so that it's turned on a quarter of the time and turned off 3/4 of the time. For example, you could turn on the output for 1/10 of a millisecond and then turn it on for 30 milliseconds. On for 10, off for 30, and so on. Sounds like a lot of work, and it can make your sketch quite complicated if you can try to control all the timing yourself. But luckily, Arduino has a special feature that makes it relatively easy to use pulse width modulation on certain outputs. If you look closely at the labels on the header, and you'll see that some of the pins have a tiny PWM label. You can use those special outputs to control things like the brightness of LEDs. I'm just looking now. Yeah, I can see various ones that have PWM written on them. Inside the microcontroller is circuitry attached to those pins that accepts a setting to tell what duty cycle to run at. Then it keeps turning the pin on and off very fast to maintain that duty cycle. Once your sketch has told the pin what duty cycle it should run at, and the sketch can continue doing along other things, the microcontroller will keep the pin going on at the same duty cycle until it's told otherwise. Hey Dana, what's up? Not too much. Learning more Arduino, one step closer to building my own controllers. We're getting there, very slowly. Alright, so we have new sketch to mess with. This would be Project 5. Sketch. Old one. It's redundant. Down a little. And paste it in. Excellent. Alright, so let's have a look at this code and try and work out what's going to happen. We're using pin 11. Yes, we are still using pin 11. The brightness equals 0. Delay time equals 10. Okay. Setup. Pin mode, LED, which would be pin 11, to output. So that's to be expected. Now we start the loop. While brightness is below 255. Analog right. LED brightness. Delay equals delay time, 10 milliseconds. Brightness equals brightness plus 1. So it keeps getting slightly brighter. Yes. And then while brightness is greater than 0. Oh, wait. Yeah. And so that it'll keep. Yeah, so it'll keep getting brighter until it reaches a brightness of 255. Then it will start getting darker till it goes off completely. Wait, I think it works. I wonder why they picked brightness 255. See. To be honest, that's one thing I dislike about the T16000M, the stupid LED wasting electricity. Well, that's easy enough to fix. You just snip the right wire. Let's turn this on, see what happens. But it should get bright and then dim. Then get bright, then dim, and so on and so forth. Wait, that's a bad idea. I haven't plugged it in. Yep. Now it should work. That's getting bright. Going dim. Cool. I think it's working as intended. Do I understand? Like, yeah, the only thing I don't understand is while brightness. Analog right. Huh. Maybe 255 is the highest value you can get for pulse width modulation. It goes to 255 because analog right takes values. Okay, have 0 to 255. Thank you, hello meow. Appreciate it. This is just C code being used. At least I believe it's just C code. Correct me if I'm wrong, but I think it's just C. I need to learn a lot more C because I don't know much yet. Also, I think there's a spot in your camera lens or shadow because when you lead forward, it looks like you're being punched. No, that's the camera that's blocking my... Yeah, camera that's blocking light. So don't worry about that. Yes, the lighting isn't ideal, but it'll do. So that works, piece of cake. Go back over here and we'll see him explain stuff. How the software works. By now, most of the code in this sketch should be quite familiar. Yeah, I'm getting the hang of this. There are some oh god, it's explaining what I was wondering about. There are some variables declared at the start. This pin mode is set. I've got to really read this first. This pin mode is set in setup, and then there are 2 loops. The first steps the brightness value up from 0 to 155, and then steps the brightness back down again to 0. The new part of the line is analog right, which tells the pulse width modulation capable pin to pulse with certain timing. With a value of 0, the pin will permanently be off with a 0 duty cycle. With a value of 255, the pin will be permanently on. 100% duty cycle. So I've actually done this before, this part, or at least I would have copied the code, not necessarily understood it. Value of 127, the pin will be on half the time. 50% duty cycle. By stepping the value up from 0 to 255, the pin will rise slowly from not on at all to fully on all the time. The LED will also start totally off and gradually illuminate until it's totally on. The human eye result is very simple, with a smooth transition from off to on in 256 steps. .255 FF in hex, which is the maximum you can write with 8 bits. 8 bits? I need to be more than 8-bit. The T16000M has 16-bit positioning, I think, if I remember right. I don't think, by the sounds of it, the Arduino isn't actually even capable of that. I think I've heard like the Arduino was mentioning 1,000, like 1,024 different positions it can register. So it's not actually as accurate, funny enough. And can't be, I don't think. I don't know, maybe there's ways to mess with that. I'll worry about that down the track. Further experiments. Combine this project with a light sensor. You could make a night light that varies the illumination level depending on how bright the background light is. Start with a sketch in the previous project and restructure it so it loops isn't delaying different amounts depending on the light level. Instead, it sends different values to analog right to change the brightness of the LED. Remember though, analog write needs values between 0 and 25, while analog read gives values between 0 and 124. That means you will need to proportionally scale back the reading from analog by dividing by 4. So I'm guessing, do you just do /4? You do just /4. Let's try that program and see how it goes. Example 2. Paste. Upload. What have I done? Missed part of the code. Not that it's difficult to fix. I just need to add bracket and not add a Z. So now the brightness should get brighter as I cover. Oh wait, I haven't put the light sensor on. I've got to reattach the light sensor. Yeah, about that. Let's reattach the light sensor, shall we? So let's unplug that. Do I remember how the light sensor works? Let me see if I can just remember. Probably not. Let's just do it the easy way and scroll up, and then I can see what's required. But I think, how's it go? 5 volt. Oh, that's the wrong one. 5 volt gets directly connected. Wrong way. It's a Freetronics copy, but it's the equivalent of the Uno. Yeah, the 5 volt gets directly connected. I did get that part right. Around, directly connected. Of course, there's no resistor because it is the resistor. And the other one goes to a pin. Which pin? Analog input 1. Well, 0, sorry. And I put the positive in the wrong one. Need to move it one across. Electronics. Gotta love electronics. Alright, replugging it in, hoping for no fire. I really should have a fire extinguisher nearby. And upload. Here we go. That's not right. It's supposed. Why would it get darker when, like, why would the LED go out when there's no light? It should do the opposite. And we know how to do that, don't we? That, what was it? What do we do again? 1, 0, 3, minus. Do I need to do brackets or I don't know how this works. I should have. I need to do brackets, but how does that work in computer code? Because if I do brackets, it's going to get really confused. Maybe if I do, maybe if is it square brackets that you do? Let me try that. It's the worst that could happen. Nope, doesn't like that. Let's just try it without anything. We'll just see what happens. Use the curvies. Curvies it is. Someone's yelling happy birthday. Apparently it liked that. Now it's not doing anything though. As the light level goes up, shouldn't it get dimmer? I don't even know if the light level is registering. But of course, we're using serial print. I can check what the light levels are. The light levels are never getting very high. Let's pull out the phone. Yeah, if I do that, the LED... Yeah, it's just that it wasn't responding enough. If I do that, the LED goes out as it senses the light. That's working. It's just it wasn't making enough of a difference to be noticeable. Alright, turning the torch off. Alright, Mercenary Thorn. Aaron's. Circle ones, braces are the fancy squiggly ones, and brackets are the square ones. Oh, I really need to learn code. I'm slowly picking it up. It's taking a while. Alright, so this is functioning. That's good. So we've managed to attack that. Let's see if there was anything else mentioned in this dimming experiment. So we just did this one. Alright, we're up to actually messing around with servos. Alright, hate to say it, so I'm actually going to be finishing the stream up there. I know I've only been on for about 2 hours, but unfortunately I have to wake up at about 4:30 for work tomorrow. And I'm getting a headache, and I have no idea why. Maybe it's all this thinking. Oh, I'm not used to this. I just want to shoot things. I am enjoying doing this, though, without a doubt. But it is a lot tougher than just shooting things. Shooting things is... Pull the trigger. It goes boom. So, if you've got final questions, comments, stuff like that you want to throw my way, now's the time to do it. I don't think I'll fit in any extra streams this weekend, but wait and see. Failing that, next week, I really do want to keep attacking this because I'm eager to keep doing this so I can make control boards for both Elite Dangerous and Star Citizen. I personally think that would be rather cool, but I might be a nerd. Quietly. You've got to go too now? No worries, Dana. Hopefully I'll actually get to the point where I know enough about this that I can actually teach people who want to do it. Not necessarily, advanced electronic projects, but enough that, if they want to make a control board for a space sim themselves, that they can do it. That's pretty much what my goal is. So I need to be very good at the coding that's related to that. And maybe if I want to get advanced, even the ability to do small little monitor outputs, which Arduinos can do to display information. But that's getting a little more advanced. And then, yeah, I don't know if it's possible to set things like curves and such. Should be, I guess, in theory. Of course, you'll have to dive into the code to change the curves. But I don't see, given that we can do mathematics in the code, I don't see why we couldn't add curves. It's something to think about in the future anyway. Joystick curves could be fun. You gotta go? Yeah, no worries. All right, well, I'm going to jump out of here. I'll be back on Monday at my normal time. Who knows? I might even manage to come in the morning to fit in a bonus stream. I think definitely my first project when I'm done here, done with their actual programmed all the tasks in this kit will be to make just a very simple controller box that I can use to switch scenes when using Twitch, because just it wouldn't be that hard to make and it'd be incredibly handy for me. Oh, GG. All right. Thanks as always. I appreciate people showing up, following, watching, subscribing, donating, and putting up with me being very, very nerdy. Cheers. Good hunting. Haha. By the way, if you want to recommend another streamer, feel free to. Don't block links, so go nuts. Cheers, good hunting.